Welcome to another interesting test question on vectors. You need to find power of an elevator which moves up 10 meters in 5 seconds. What is power? How do we calculate it? Well, it is a dot product. We will see its derivation and the solution in this particular video. Let us enjoy the journey of success and learning. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. Here is a question from one of my students who wants to understand how do we calculate power. The question here is, an elevator weighing 5,000 newtons moves up a distance of 10 meters in 5 seconds. Find the power of the elevator. So the major question here is, what is power? So let me write down this question. What is power? How do we calculate it, right? Clearly in the topic, we have mentioned power, a dot product application. Let us try to understand this, and then it will be very simple to answer the question. Power is rate of change of work done. So if power is P, then we can write down power as rate of change of work done. You get the idea. That is how power is defined. The units for powers are watts or joules per second. Now, you know that work done is the dot product of force and displacement S, right? So it is dot product of force and displacement, right? So now, what is power? You can derive the formula from here. Perfect. So at this stage, I'd like you to pause the video, answer the question, and then look into my suggestions. So now, we know that power is rate of change of work, which is d dt of force dot displacement, right? So it's a dot product. Now, if you do the derivative of these two, in that case, what do you get? You get derivative of f with respect to time over displacement plus f dot derivative of displacement with time. Now, in the question, we have force, which is constant, and is equal to 5,000 newtons, correct? So when the force is constant, we know that derivative of force with respect to time is going to be 0. And therefore, for a system in which force is constant, power can be written as force dot rate of change of displacement. And you know, rate of change of displacement is what? Is velocity. And that is how we derive the formula for power. Is that clear to you? So let's write down this formula here, that power is basically equal to the dot product of force with velocity. So power is a scalar quantity. And the units are watts. Is that clear to you? Now, keeping that in mind, let us now solve the question. The question here is, an elevator weighing 5,000 newtons moves up a distance of 10 meters in 5 seconds. Find the power of the elevator. So, if I draw a free body diagram of the elevator, then we know that this weight is acting downwards, and this is 5,000 newton. However, the system moves up, right? Since the system moves up, we need to apply equal and opposite force in the upward direction so that the body can move upwards. Correct? Now that force will assume to be equal to 5,000 newtons. You get the idea. So that is what we are going to assume. So when we want to know, find the power of an elevator, right? So we want to find the power of elevator. So in that case, we see that force is 5,000 newtons and is being applied upward, and the velocity is 10 meters, and the distance of 10 meters is covered in 5 seconds. So the velocity is 2 meters per second. And therefore, the power, which is basically equal to dot product of force and velocity, can be written as magnitude of force times magnitude of velocity times cos of angle between the two. And this is equal to 5,000 newtons times the velocity of 2 meters per second times cos of 0 degrees, which is 1. And therefore, we get this answer as 5,000 into 10, which is 10,000 watts. You get an idea. So that is how we are going to calculate the power of the elevator in the given question. I hope the concept is absolutely clear. In case you want to learn from me, you can always write an email on the address given. If you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.